Okay, here we go. One-to-one functions. Very simple idea here. If I explain this just right, you won't even worry about this anymore. You won't have to study it or anything like that. You'll be like, oh, I totally get that. A function is a relation for which each element of the domain corresponds to exactly one element of the range. That is, for each x, there's exactly one I. These relations pass the vertical line test. Hopefully, we beat you to death with that along the way. And we acted like this was, why wouldn't functions all be like this? Every x value has their one y value. At every t, you have one height. At every time you measure something in chemistry, you're going to have one concentration or one temperature. It seems like, why wouldn't everything be like that? Well, of course, everything's not like that. But a lot of science stuff is. There's tons of science and engineering and computer science stuff that are functions. We call them functions. They're a little easier to analyze. And so that's what we've been working on mostly over the years here. Furthermore, we haven't talked about this, but a function that is one-to-one, if we have each element of the range corresponds to exactly one element of the domain. So this is the horizontal line test now. It can only be one-to-one if each x has one y and each y has one x. Why are those functions so important? They invert nicely. Doing the inverse is very, very straightforward. That's the big picture of what's going on. You don't need to know all that just yet. What you need to know is, okay, one-to-one, not just vertical line test, it's got to pass the horizontal line test as well. And we call that a one-to-one function. Yes, good. Circle all the one-to-one functions. Maybe it's easier to circle the ones that aren't one-to-one. It's almost easier to recognize ones that aren't one-to-one. Is this a one-to-one function? Here's the two tests. It's got to pass vertical line. This does. It's a function. Does it pass horizontal line test? No. So that's not a horizontal line test. It says circle the ones that are, but in my brain I have to X out the ones that aren't. That's a little easier for me. What about this? Passes vertical? Yes. It's a function. Passes horizontal? Yes. It's a one-to-one function. I haven't really beat to death why it's so important we want one-to-one functions. I just sort of nudged at it. For now, we're just using the definition. What's one-to-one? It passes both vertical and horizontal. Okay. Passes vertical line test? Yes, it is a function. Passes horizontal line test? No, that's not a one-to-one function. It doesn't do inverses nicely. I'm planting the seeds for next Monday's lesson of why it's so important. Inverse will be difficult, or troublesome at least. Y equals absolute value of x plus 3. Well, you got to know the absolute value function before you can do this. You got to at least have a mental picture in your head where you can go, okay, what was that absolute value function again? Oh yeah, like this. You forgot, you jam it in your graphing calculator real quick. It has absolute value in there. It's in the catalog of functions to get absolute value. Sometimes you have to use the catalog. We'll talk more about that when we do. Anyways, this is move 3. I don't really care that it's move 3 in this particular case because I can look right at it and see it fails the horizontal line test. This is not a one-to-one function. Oh, I was doing that in red. There that goes. Finding the inverse of this, you found that out in advanced functions. Finding the inverse of absolute value is a royal nightmare. It's got all sorts of difficulties with it. 4th root x plus... what do root functions look like? Yeah, there's sort of a half a sideways parabola. That's important here. It's only this part of the parabola sideways. So that means this thing will pass the vertical line test. It's not like a parabola. Square root functions are nice in that way. 1 over x squared plus 5. I'm going to come back to that. That one's a bit of a problem. We're going to come back to that in just a second. Plus or minus root x. Ooh. I know I'm changing colors back and forth, but here you get the plus root x, but you also get the minus root x. And so that immediately fails the horizontal part. Oh, sorry, the vertical part. It's not even a function, let alone a one-to-one function. This came up for somebody in the homework. The basic shape of these things. -2, 5 to the x. What do exponential functions look like? Sort of level out on one side and take off out the other. These are exponentials. This one happens to be upside down, up at 7, so I'd need a pretty good graph of it if I had to do domain and range. I don't need to do that here. I just need to know if it passes vertical and horizontal, which it does. So it's 1 to 1. Okay. Every x value has one y value. This is a function. Does every y value have one x value? 10 goes to 1. Ooh, 10 also goes to 5. So you got to do this reverse mapping thing to check if it goes back the other way. You can stay with the lesson if you like. It's great stuff, 1-to-1 functions. So good. Can you see that? In table values, it's just a little bit more difficult to see that coming. Every x has to have one y, and every y has to have only one x. This y of 10 has two different x values. Perfectly legitimate table, perfectly legitimate setup, no problem. It's a nice function, but it's not a 1-to-1 function. Doing the inverse of it will be difficult. And this, every x, oh, what? No, this isn't even a function. 1 goes to 90 and 1 goes to 50? That wouldn't happen in a lot of scientific processes. You wouldn't go, oh, at time 1, temperature 90, time 1's also temperature 50. Sounds good. Have a good weekend. I'm positive. Little math joke. It'll be halfway down the hall, should be like. Positive. Such a nerd. All right. 190, 150. Not even a function, let alone 1-to-1. Leaving only this one as the really difficult one. 1 over x squared plus 5. It's the only one I'm going to think about algebraically. If I put an x value in there, say 2, just to throw an x value in there, will I get only one answer? Every x value I put in there. So if I put 2 in there, I get 1 over 9. One y value. There's no way to get two answers out of this. This is a function. Yeah? Never really spent much time talking about them algebraically like that. If I put in a 14, I'll get an answer. Now, let's go the other way. If I put a y value in there, is it possible to get two different x values? What is it about this situation that tells me I could get two x values? Yeah, the squared, right? So this is not 1-to-1. Yes, function. No 1-to-1. Said another way, if I put 2 in there or I put -2 in there, I'll get the same y value. Yeah, because they both square and become 4. Oh, yeah, you really got to go to get the shape of it. Here we go. Where was I? 10 to 10 Cartesian graphs? That'll do. Okay. X squared plus 5. And I'll just do shape. That's what you asked for. Not a specific graph, just shape. X squared plus 5 looks like this. Something like that. I know I haven't done a very good job of going through the actual points and using the 1-3-5 rule, but the shape. Now, we did this 5.1 in advanced functions. Reciprocal functions, 1-over functions. And you're just basically going 1 over all the y values that are in there. So for instance, 5 would become 1 over 5, right about there. And then the numbers would keep getting bigger and bigger. If you go 1 over something bigger and bigger, you get something smaller and smaller. And I got to tell you, if you zoom in on this thing, it really looks like this. Yeah, it's really low there. Yeah. And then this way, the same thing. Gets really big, so here we're going to get really small. Difficult to see in that picture how it's not 1-to-1, but in this one, you can see not 1-to-1. Boy, that was one section of advanced functions. We didn't really spend a lot of time on it. There's one day where I had to go do some homework where I had to think like that. That's really reaching, you know? So that's why I did an algebraic explanation instead when I went after it. That's not what we want. This. To say, okay, if I put 2 or -2 in as the x, I'll get the same y, so it's not 1-to-1. Good? How many pages is this? 12, and I promised half an hour, right? I'm 2 for 12. Okay. Questions, though? Ask me questions, though. I'm rushing it for your sake, so you can have 55 minutes of work time. I believe this lesson gets to some stuff that's a little faster. Here we go. Getting formal. Definition of a 1-to-1 function. This is just what I said before, but just the formal language. A function is 1-to-1 on a domain D if it never happens that f at A equals f at B, if you never get the same y value. In other words, a function is one-to-one if it never takes on the same value twice. Here, not a one-to-one function. F at x1 is the same as f at x2. Two different times you get the same y value. x1 and x2 are different, then the y value should be different. Inverses. Okay, this is where we're going with it. Inverses are really important. Seem like this crazy thing you did in grade 11, these inverse things. But every function has an inverse, and we used it. Add, we immediately learn subtract. Multiply, we immediately learn divide. Squared, we immediately learn square root. We always want to be able to undo these functions. Exponential, we much later learned logs. Yes? So that's coming up in this lesson too. So, if you've got a function that takes 1 and turns it into 5, 3 turns it into 7, 8 turns it into negative 10, the inverse function will do the reverse. It seems like reverse would be a better word here than inverse. Yeah? It just means it undoes what you just did. So picture it this way. If an x goes into the function f, it becomes f at x. Then you put it back through the inverse, you go back to x again. So if you go from 2, and this takes 2 and turns it into 8, the inverse takes 8 and turns it back into 2. That seems weird until you actually put a function in there. Let's say this is the squared function. Put a 7 in, square it, 49. Then square root it, you're back to 7 again. That's what inverse does. It takes whatever output and puts it back to whatever the input was. So that's where these come from. If you do the inverse of if you take a function, operate, and then do the inverse, you'll be back where you started. It doesn't matter which way you do that. If you square and then square root, you end up back where you started. And this says, if y is the inverse of x, then f at y equals x. So you put the y back into the original function, you'll get your x value back out. These make it seem more complicated than it is. Don't get hung up on these, actually, just yet. Just remember square and square root. Yeah? 5 squared is 25. Square root of 25 is 5. They just go back and forth like that. Oh, determine the equation of the inverse. There's one on the test like this. Here, now I have your attention. Wake up. Here we go. I do have to ask once on the opening test to find an inverse. You did this all the way back in grade 11. We did very little of it in grade 12, so a little review here, and I'll actually write the steps to finding inverses. The steps were, write f at x as y. There's almost no reason to actually do that. The only reason to do that is so that the algebra looks a little more familiar. This is an algebraic move. That really doesn't do anything except make your algebra a little easier. Step 2, exchange x and y. This is where you really do the inverse. Make the outputs the inputs and the inputs the outputs. 3, solve for y. I'm starting to speed up here because I hope of everything I've talked to today, this is the one that sort of rings a bell the most. You're like, oh yeah, I remember doing the inverses. Here we go. So what do I got to do? Go slow here. X plus 6 equals 2. Y minus y squared. Divide by 2. Mistake coming? Because I really want to talk about it in a big way. Step 4, write the new y as inverse. F inverse, careful now, F inverse equals square root x plus 6 over 2 minus 5. Okay, now I'm going to switch colors and draw your attention to a little thing that caused people some heartache last year, and I don't want it to cause heartache this year. What did I neglect? Yeah, the plus minus. Okay, now here's the big explanation though. Because this is an even power, when I do its inverse, you need plus or minus. There are two different values that will give the right answer here. That is, 5 and negative 5 both squared to give 25. So when you're undoing, when you're square rooting, you need plus or minus. Here's my big sentence though. It's not true in odd powers. It's not a problem with odd powers. You don't get those kind of results with odd powers. So this is an even power move. Only when you're dealing with even powers do you have to have the plus or minus. So here plus or minus, and here plus or minus. And in blue, only when inverting even powers. What a horrible job I did of explaining that last year, and then it tripped some people up when a cube appeared on the test. Questions about that? Does this seem really familiar? You've been inverting for a while. The only difference, if this had been a cube, instead of square root, I would have done cube root, but I wouldn't have worried about the plus minus, because it's an odd power. Questions here? More time? More time? Check for any texts that people with their concerns that they want addressed. Do I know my code? No, I don't know my code. Oh, no text from anybody? All right. Good? More time? Say it again. Minus 5 became plus 5. You're right. Okay, good. Good correction. That's a plus 5, isn't it? Yeah, good. I did something similar earlier, didn't I? Yeah. Getting old? Good? Got that correction? Graphing inverse parametrically. This will go quick because it is so nice and easy. When it's in parametric form, inverses are so nice. If you've got two graphs that you're graphing, sorry, you got a graph that you're graphing where the x is t and the y is f at t, you can just flip those two to get the inverse. Make the x the f at t and the y the t. It's actually that easy. So you're really just reversing the roles of x and y when you're doing parametric. So the use of parametric equation allows us to easily graph a function that's inverse using technology. So this is a crazy one. At first, it first looks like, oh, how are you ever going to come up with a parametric equation for this mess? Yeah, it's actually so easy. You just go like this. You go, okay, let x equal t. There's the first part of the parametric equation. And now here's the second part. Y equals t cubed minus 4t squared plus 5t minus 7. What a great choice for parametric equations for this. It's almost like, why would you even care about parametric in these situations? And it's because the inverse is so easy. Imagine inverting this. It's a complete giant nightmare. It might not even be possible to do the inverse of that Cartesian way. But for parametric, you just go, okay, then that means x will be t cubed minus 4t squared plus 5t minus 7. And now the y will be t. So nice to do inverses parametrically. You just literally take the x equation and make it the y equation. You make the y equation the x equation. And it wants me to graph these things. Okay, now, I really think that when you've been graphing a lot of stuff parametrically and so on, and you're a little worried, I think it's a great time to do that menu system thing and go and just go down to F5 for reset and reset the main memories. That way all the changes in settings and everything, they're all gone right now. So that is a great way to handle that. And I want to talk about this because some people ran into this in the break. Now when you're graphing, instead of just jumping in and graphing, you got to think, am I doing parametric or not? And here we're doing parametric. So, yeah. Type Parmesan. First graph. T is the first parameter, and the second, is the x equation. The second equation is t cubed minus 4t squared plus 5t minus 7. And I'm going to graph the other stuff. I'm going to do everything it says. But for now, I want to graph that because I know some of you are still running into some problems with graphing. And I want to talk about how to deal with things that go wrong. Remember, I reset. The nice thing about reset is that now it takes a shot at my new situation. I hit draw. Ugh, look at this. Did you get that? Was yours better than that? Yeah. So then my first move is always go zoom, auto. That didn't really help. Yeah? That wasn't much better. So I'm going to go to V window, and I'm going to try negative 10 to 10. Negative 10 to 10. Exit. I'll try graphing that. And now I can see a lot better what's going on. And now I can change my zoom settings and so on to zoom into what I want to see there. Sort of looks like to me that a better window would be negative 2 to 5. So let me try that. V window, negative 2 to 5. I know your generation is very lucky. You got iPads. Zooming to you is just, you take your fingers and you do woo, 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 and you move it around. These don't have that. And when we just say it one more time, though, for graphing, iPads and iPhones are better. Absolutely. You just don't get to use them on the tests and exams around here, so it's worth it to learn what this thing does. Okay? Decent little graph there of this cubic function, cubic type function. Then it asked me to do the inverse. So I'll go back to here. And the next one, the x this time is the t cubed minus 4t squared plus 5t minus 7. And the other graph is just the t now. See how nice that is for inverses? And I draw them, and woo! I can't see that other one. So I'm going to go back to V window. What did I decide? Negative 2 to 5. So that's it. I'm going to go negative 10 to 10 and see if that comes out better. Exit, draw. Can you see the two of them now? One's like this, and one's like that. But I'm glad I got to show you that sometimes you just got to play around with the window settings. That's the weakness of the calculator you got in front of you. Yep. Questions about pumping that stuff in? 6 minutes I'm down to. It's going to be close. I think it goes faster after this. T cubed minus 4t squared plus 1. That all looks good. Oh, minus. Between t cubed and 4t squared there. Yeoman? Then this one's got to be a t again. Yeah, because we changed the roles of x and y. So the first set of parametric equations was x equals t, y equals t cubed, blah, blah, blah. Then the second set is the other way around, which for finding inverses parametrically is real nice. You just reverse the roles. Yeah, you need both for parametric, yeah. Oh, it's just the window. Let me just look at your, we'll hit this F6 here. T cubed minus 4t squared plus 5t minus 7. And then you'll just go to Windows negative 10 to 10 or something like that after you draw it. Yeah, see, you got giant y values. For whatever reason, it jumped into some giant y values. Go negative 10 to 10 and you should see it a little bit better. It's you. You're blowing these things up, are you? You're like, what was that in the one superhero movie? Person comes anywhere near electronics and it blows up. Okay, try it again. I did the reset in the back of it. If Jamie asks to borrow your phone, don't lend it to her. All right. Hey, review of logarithms. Did I do logarithms last, or did I move it up in your advanced functions course? Did we do logs last? Oh, yeah? You're probably, can't even imagine how you're handling that in June out there. You're like, let's just get these answers down and get started our summer, yeah? Let me just review logs just a little bit. Log base 2 of 32. What does that mean? It means I'm looking for an exponent. I'm looking for the exponent. You got to put on 2 to end up with answer 32. Let's see. Is it 2 to the power 1? No, 2 to the power 1 is 2. No. Is it 2 to the power 2? No, that's 4. 2 to the power 3? No, that's 8. 2 to the power 4? No, that's 16. 2 to the power 5? Oh, there it is. 2 to the power 5 is 32. That's what logs are all about. You want to read this? You say to yourself, I'm looking for the exponent. Base 2 to get 32. That's an incredible log lesson right there, just to write those words in there. What does this even mean? A logarithm is an exponent. So let's try this one. Log base 5 of 1 over 125. Well, 5 squared is 25. 5 cubed is 125. 3 is involved here. How are we going to end up with 1 over? Negative. Yeah? And these are the type of questions that help you learn what are logs about. Yeah? Oh, look at this mess. Log base 4 of 3, third root of 16. Any way to really handle this is to go something like this. There's some grade 11 review for you. Third root means exponent 1/3. Now here's some logarithm review for you. This was the big thing about logarithms. Somebody ran into this the other night. Once you have a log like that and you've got an exponent up here like this, the exponent can become the multiplier. It's one of the log laws. Tough to comprehend, to really understand it. But it's a really nice thing in this situation because you can bring the 1/3 down. And if you're having real trouble with this, here, start with this part. If you're like, oh, I don't remember logs at all, start with this. Log base 4 of 16. What exponent do you put on a 4 to get an answer of 16? 2. And if you're like, okay, I know that, then you know logs actually. You just got to get used to the words. 1/3 of 2, which is 2/3. Okay? Nicely, there's some nice log homework here to pound away at if all of that stuff is like whoosh for whatever reason. Yeah? Coronavirus being one of the reasons. Maybe you're out of gas in June and you just grab someone else's assignment and send it in to Mr. Todd, or whatever, however you handle these logs at the end of the year. Here to here? Oh yeah, here to here. I'll explain that 2 ways. Okay? The first one I'll say is it's magic with logs. Yeah? It's log law 3. It's by far the most important log law. And it says if you've got an exponent inside a log, you can put it out front as a multiplier if you want, if that's easier. Sometimes you want it up there, sometimes you want it down there. It depends on what you're doing. All right? Great for solving log equations. Back to my untitled one here. Here's why we liked it so much. Say you got 3 to the x equals 100. Really difficult question because we never taught you logs before. But if you put a log on both sides, in this case log base 10, log law 3 jumps right in and says, if you want, it's up to you. This exponent can come down and be a multiplier out front. And in this case, that is great stuff. Because now it's a multiplier, and I can divide by the log 3. And now my calculator can punch out the answer. Okay? That's the big advantage of logs and of log laws. Because solving for an unknown in the exponent before logs came up was trial and error. You might remember this in grade 11. Is it 3 to the 4? Is it 3 to the 5? You just kept typing in things. But logs deal with it right there. How do they deal with it? Take logs of both sides so you can bring the exponent down in a one quick sentence. Is this ringing a bell? It might not be. Like I say, and I don't mean this to be a jerk about what happened in June. We were dying at the Todd house too. You were dying out there. It could be you did all sorts of things to get that last log assignment in. Some of them honest and some of them not so much. The result of that is your log knowledge might be a big 0 at this point, in which case you got to get back into those things. Those log lessons are still up on my YouTube page and so on, but we got to get the basics of logs back down again, where you can handle these situations. Your textbook's a great resource for this too. They do some nice stuff in there. Like I said the other day, your textbook is good. You can read and go, oh yeah. No, maybe it's not even recall. It's like, let me just do a little reading on logs, the stuff I didn't do back in June, right? Where was I? Here are the log laws, though. If you've got two things multiplied inside a log, you can break them up. One of the things you're allowed to do. Why would you do this? If it's convenient to do so. Sometimes it's convenient to do that. If you've got two things divided, you can turn them into subtraction. And this is the big one. By far the most important one. If you've got an exponent there, you can bring it down out front. Sorry, I'm unhappy with my quality of writing here. And these are great fun. Especially if you did the log stuff and you're sort of remembering how logs go, you're really going to get this. It could be, if you're just getting going on logs right here, this is your moment, that these last three examples are like, woo, maybe later. I'll come back to these a little later. The exponent you put on a to get a to the power of x is x. What do you put on a to end up with a to the x? You just put x on it. It's so ridiculously easy, it's hard. Here's a. And what exponent does it have on it? It has the exponent you put on a to get x. So of course you get x. Of course, I says. Those of course words probably scared you. You're like, of course? What of course? This is one of those coronavirus moments. We're going to need we'll do some work on logs over the next 2 days. I would have said 9 days, and then you're going to be like, worried about your other class in there. Now, this one. I don't prove this here, but you can do any log with any calculator just by typing it in like that, using log base 10. And I'll mention that when it just says log of something, we mean log base 10. It's called the common log. It's almost always base 10 we use. He said lying, but it's just so common that we don't always write the base 10 there. Maybe we should, but we don't. Okay, I want to show some of that stuff in action. I don't want to get hung up on these pages of rules. I want you to see, well, oh, it's right there. I forgot it was here. Log base 10 means log. Here's a new one. This wasn't in the advanced functions course because we hadn't done E yet. Log base E is so important, we call it ln. If you look at your calculator, there'll be a ln button there. And that is not going to go away. How do we solve these equations? Okay, here we go. Solving exponential equations. How do you know you got an exponential equation? Unknown in the exponent. Start by trying to isolate. Divide by the 2. And now I'm going to put it to you. I've actually taught this in this lesson, but it was in the log homework, huge, in advanced functions. Now what? Long pause to let you think. Long pause to let you panic, maybe, to go, I don't know what to do, so that the answer is meaningful to you. What do? Logs. Log both sides. This is the most important thing about logs. At first glance, if you don't know log law 3, you might be like, that just made a bigger mess. Thanks a lot. That's just more confusing now. But log law 3 says if you want, if it helps you, take the exponent inside of logs and put it out front as a multiplier. And this turns this very difficult question into something easy to solve. It might not be easy to write. To get x by itself, you just go log 8 and divide it by log 1.75. And you don't need your fancy calculator to do that. Any calculator will have this log button on it. Jamie's won't do it anymore, but sorry. Menu 1, log 8 divided by, maybe you should try this to make sure you know how to type in logs. Do you get 3.7158? And then I'm going to put a little dot over the equal. I think the back of the book does a double squiggly for when it rounds off, which they really shouldn't do. That's not really, that's supposed to be used for something else. But anyways, they just mean, hey, I rounded this. Yeah. Okay, check out this one. Solve this equation. Again, solving exponentials, you know when you have an unknown in the exponent. That's how you know you're going to have to use log somewhere on the way. But you start by isolating. 6. This has got an e as the base now, which I hope that doesn't freak you out. You're like, okay, apparently e is an important base. Apparently. We just found that out on Wednesday. What, 211? Keep isolating. Now, I hate to blow your brain up on a Friday, but it's just too good what I have to show you next. This is one way to do it. It's fine. It's good. You can probably go your whole life solving exponentials that way. But this is better. It's a little harder to understand, though. Let me go through it. When you move across an equal sign, what you get is the inverse. That's not the way we say it when you're first learning equation solving. We say, oh, when you move over, it becomes negative, and that screws people up. We should have said the whole time, right from we were first solving equations, we should have said add becomes subtract when you move to the other side. Subtract becomes add. Multiply becomes divide. Divide becomes multiply. Squared becomes square root. You become your inverse when you move across an equal sign. The inverse, this is so good. This is the best line of the day. Best line of algebra of the day here. When e to the power of moves over here, it becomes ln. If you're confused, that's okay, because that's a different way of solving than this. This uses logs to go, I'll do logs on both sides, and I'll use log law 3 to manipulate things. This uses inverses. It uses the same thing that you've been learning about all through school, which is that we solve equations by doing inverses. My kids are going to love you guys. I won't be able to yell at them all weekend. This is hard, folks. You could do this question right here by doing logs of both sides. Absolutely. Will work. No problem. You get the same answer. But I want you to continue to try and grow, because this is so nice. The inverse of e is ln. So beautiful. And we're going to keep coming back at it. By next week, if you're like, no, I don't got that yet, I'm still dealing with logs, that's fine. You get the answers. It's no problem. This is just, hey, let's show you some more advanced moves, you know? Let me show you how to use that lightsaber in the right way here. Yeah? This is how we kill the Sith right here. Okay, anyway. You don't even know what I'm talking about. Happened last year. I'm like, said Darth Vader, and the kid says, who's Darth Vader? Well, chucked him out of my class. Right. Okay. Okay, don't panic. Okay, please don't panic. This kind of stuff is not what keeps people out of university. You eventually learn this stuff. You know, you just got to practice it, try it out, work with it. It'll be all right. Yeah? More time there? Here's the big hint, though. You know this stuff's coming up, either logs or lns, when there's unknowns in the exponents. And I promise you, it will not be your long-term problem. You'll get used to this. Yeah? It's no different than square and square root, actually. It's along the same lines. You just have to get used to how to solve it. When you first learn to solve a squared equation, remember that's been grade 9? Back to this. Or in grade 8. And the teacher said, oh, square root. And you're like, what? So what? You take your 9 and you put a little check mark thing around it, and that gives you the answer from the squared? And the teacher went, yeah, that's what you do. Yeah, and then later on it's like, yeah, of course that's what you do. It just took a little while. It's not hard. It's just new. If your brain's exploding right here, this isn't hard. Just new. Give it a chance. Yeah? Work your way through it. It'll be all right. I'll tell you when we get to the difficult stuff. This ain't it. All right? 4 slides to go. Oh, another good one. Solve the equation for y. Here I go. Ln y plus 8 equals 3 plus 2x. I've moved the 2x over there. Trying to get y by itself. Another big moment, which will seem completely weird. If you're just learning it as I do it here, that's okay. The inverse of adding is subtracting. Subtracting, adding. Multiplying, dividing. Dividing, multiplying. Squared, square root. Square root, squared. Ln e. What, the little check you do just reverses squared? Yes, that's exactly what it does. Go home and do 1,000 of them. And you'll get used to the fact that square root reverses squared. You're saying that if I got ln over here, I just move it over and it becomes e to the power of? Yes, that's what I'm saying. That's what it is. It's the inverse of ln. It does the opposite of ln. So then I'm done here. Y equals e to the 3 plus 2x minus 8. I can hear my tone of voice. I can hear it on the speaker. It sounds like I'm like, oh, it's so easy. No, I don't, it's completely new. It is easy. It actually is easy. It's just new. Give it a chance. Yeah? Try some of these. Go home and don't do your homework for a week. Yeah, you're going to get clobbered. Of course you are. It's time. You've had lots of years of sort of doing your homework. Now we got to do it all. Do you have questions about that, though? Besides what the heck is going on? Oh, he says, can I try the next one by itself? No, this is completely difficult again. This is so hard. This is crazy, this one. We just went from low, difficult. Okay, now I'm warning you. This is difficult. What a mess. Here we go. E to the x and e to the negative x in the same question. This reminds me of when x squared and x appeared at the same time. See, let's just rewind a little bit. Grade 9s. I can even make that a decimal, and the grade 9s are not intimidated. You should not be intimidated. X squared equals 37.4. You didn't have to know anything, except the little checky-do thing. Yeah? Checky-do. And back in grade 9, it was usually about Pythagorean theorem, so we didn't even care about the plus minus at that point. Sides aren't going to be negative, so, okay. Pretty straightforward. But watch this. That is a completely different world. It doesn't seem like a big deal. All I do is put a 3x in there. But now it's move the 4 over, factor or use the quadratic formula, negative b plus or minus the square root of b squared minus 4ac over 2a. Like this is, that just went from, oh yeah, to mind-blowing. Not mind-blowing to you. You've done a bunch of them, so you're thinking, oh yeah, quadratic formula, no big deal. But just think back. Yeah, I don't know if you remember the day in grade 10 where the teacher wrote the quadratic formula on the board. You're like, are you kidding me? That's the way the grade 10's looking at it. Really? And you go, yeah, really. Don't worry, it's going to get worse, your teacher says. It was bad, but it wasn't that bad, really, the quadratic formula. That's what this question reminds me of. Don't worry about it. You'll get it. This is no big deal. Because there's two occurrences of the x. As soon as there's a second occurrence of the x, the game changes. I don't know how anybody was supposed to know how to do this 2 centuries ago until some teacher showed them how to do it. But watch the difference when I do this. I'm going to multiply everything by e to the x. So, e to the x gets multiplied by e to the x. E to the negative x gets multiplied by e to the x. And negative 1 gets multiplied by e to the x. It's another one of those moves that when you first see it, you're like, that didn't help. You just made things 1,000 times worse. If you're watching the clock and freaking out, the schedule's about to change again. Again, I underestimated exactly how much time I would need for all this. I know what I'm going to do. Anyways, back to here. E to the x times e to the x. Don't freak out. Just stick with me every step of the way. Hopefully every step of the way you're like, oh yeah, I get that. E to the x times e to the negative x. When you multiply two things together, what do you do with the two exponents? Yeah, add them. These are the same base. Add them together. What's negative x plus x? So easy, it's hard. What's negative x plus x? 0. So what I get here is minus 2 e to the 0. We'll come back to that in just a second. And over here, all I'm going to do is bring this one over. I hope that doesn't freak you out. Actually, no, I'm not. I take it back. I want to talk about something else before I do that. This is why these lessons take too long. I just can't resist over-explaining these things. Okay. Still looks like a giant mess. Or it looks worse than what I started with. But this has a squared in it now, and I gotta warn you, squared changed the whole game. In grade 9, I don't have my sign up anymore. You'll see it appear after I teach the grade 9s for a while. In grade 9, equation solving was get x over here, get everything else over there. That wasn't the strategy in quadratics at all. As soon as squared was involved, there wasn't nothing over here. Get everything over there. So you could factor or use the quadratic formula. So this is a squared, so that's what I'm going to do. E to the x. I'm going to bring over that other e to the x. And we got to talk about e to the 0. What is e to the power of 0? What's anything to the power of 0? 1. So this is a negative 2. And then I'm going to write something underneath that's supposed to help. That's supposed to help. Let's deal with the green equation first. Quadratic, you could use the quadratic formula if this thing doesn't factor. Does it factor? Is there two numbers that multiply to negative 2 but add to 1? Yes. She factor. So I'm going to keep solving the green equation. Y plus 2. Okay, I said plus, didn't write it. Plus 2 y minus 1 equals 0. Do you agree? Easiest thing I've done in 3 slides, I think. Factoring. I'm just solving the green one. I know you're worried about the red one. I'll get to the red one. I'm just doing the green one, which is supposed to help. Are we okay with the green one? Factoring? Yeah? So then I would go, okay, so there y equals negative 2 or y equals 1. That's how we solve quadratics. But this was a quadratic with e to the x's. It wasn't y's. It was y. I said y squared. It wasn't y squared. It was e to the x squared. It wasn't e to the x. It wasn't y. It was e to the x. I've gone back to red here. Let me just scream an objection. When I went from red to green, you're like, yeah, but it wasn't y. The y's are e to the x. How can you just put a y in there? Just to think. I'm going to think about this for a second. Well, what if those were y's? What would I do? Oh, I'd factor it and I'd solve it. But they weren't y's, were they? They were e to the x's. Problems aren't over yet. By the way, if you're biology, chemistry, any of those, this isn't going away. Logs and lns isn't going away. And it's the least of your worries in all of those fields. You do a few of these, it's going to be like solving quadratics. You're like, okay, this is what you do for exponentials. Okay. E to the x equals -2. The inverse of e is ln. Squared becomes just a little square root checky-do? Yeah. E moves over and becomes ln? Yeah, that's what it's there for. It's the inverse. Someone got their calculator? I don't want to find mine. What's ln of -2? Will says it doesn't exist. His calculator's not on. How do you see that coming? How do you know that ln? We never even talked about ln yet. He could have known here. Exponential function, when does it get down to -2? That never happens. You don't have to know there. He could have known here. He could have gone, oh, logs. You remember graphing logs? Here's some review from advanced functions. From some homework you maybe didn't do. There's what a log function looks like. Oh, surprised looks on your faces. That's good. Gotcha. I knew it. Hey, while it was happening, you should have. It was so funny. Okay, sorry to get sidetracked. I'm going to change your schedule so you're not going to be so stressed out about how much work you have to do when I get up here. It was so funny. So I'm department head of math, and I'm getting emails, mad emails from math teachers who are like, they're cheating. I can tell they're cheating. They're all cheating now. Everybody's cheating. You know, because we, sorry folks, we can tell. You know, there'll be somebody who does their assignment and does something like, you know, on the last line of their assignment, and then they'll do something like this. You know, brain fart, happens to all of us, no big deal. Then you write x equals 6. And then we'll get 9 assignments with the exact same mistake on it. We're like, they're cheating. We can tell they're all cheating. Okay. And I'm like, don't worry about it. Teacher's like, what do you mean don't worry about it? I'm like, well, it's coronavirus. They've had a tough semester. They're at home. It's no problem. We'll get them. When will we get them? Next grade. Yeah, we'll find out. This was a bad move to cheat on these things. You know, so what? You got a great mark in grade 10 academic or whatever course it was. Now you got to show up at 11U and you don't know what you're doing. You know what I mean? Like, just relax. Chill. If you're looking surprised at this, it's because you didn't really do the log homework. Logs look like this. They're the inverse of exponentials. And so the x's become the y's and the y's become the x's, and you get this. You know, those YouTube videos are still up there. You know, check it out. Watch some log YouTube videos and get, oh, I know what a log graph looks like. So that's the other way Will could have known. I'm going to ask Will in a second how he knew. No, that's not the one I want. I want this one, okay? So subbing in -2 doesn't happen. You can't sub in -2. You can't take, it's like square root. You can't take square root of -2. You can't take ln of -2. No, I'm just going to put a no there. How did you know? He knew from here. He knew I was wasting my time with all this. He knew you can't have an exponent on something and end up with -2. Yeah? Maybe it's not till you type in your calculator. That's okay too. Type in your calculator and go, oh, no answer. That's the time you got to not freak out and go, oh, I get what that means. This one though, ln of 1, there is an answer. What exponent do you put on e to get 1? You can type it in if you want. It's a great answer though. Find ln in your calculator, hit ln and press 1, 0. The exponent you put on e to get 1 is 0. Again, you get your calculator for these things, but there is a moment where it's like, oh yeah, has to be. This is the one Jovan asked, can we do it on our own? Can we practice one on our own? No. Crazy. Not a test question. I got to tell you, yet. But that doesn't mean you don't try these in the homework. Oh, he didn't say it. He said it's not in the test. I'm going to worry about it. Hopefully you found out, those of you who didn't do your log homework back in June. Oh, I got the assignment in, course over, all is well. All is not well. Yeah? Got to hammer away on homework. Got to go after it all you can. Question. How did I know how to do this? This was a pure experience move. I knew this was a big problem, and the only thing I could think of to get rid of e to the negative x was to multiply through by e to the x. Boy, I wouldn't put you in a spot like that without warning you. It's good to see these things, but there's lots going on here. There's lots to know here and lots to learn. We would have done better if you had been in log classes with me, with you, because I would have challenged you with a little more of this stuff. We didn't get that chance, so now we've got to pick up the pieces the best we can. You're going to pick up the pieces by doing your homework. I'm going to pick up the pieces by not doing this on the test yet. Yeah? I'm going to sort of be careful. Still got a job to do to get you ready for university, though. Here? Here? This? I just moved that over. There it is there. Anything to the power of 0 is 1. So e to the 0 was 1. Negative 2 times 1 was negative 2, and it's right there. It's good? All this math stuff coming together. You know, like grades and grades of stuff. How much time do I got? Minus 26 minutes. 2 slides to go, though. And then you got a weekend to put your life back together. Yeah? Folks, it'll be all right. Here's what I know about you. You're the strongest 30 kids I've taught yet, all in the same room. It's going to be all right. I know it. I know it. Just get in there, do what you've done before, get the work done, and I guarantee nothing I've done today, except this move. This was a crazy move. Everything else is just stuff. I know, coronavirus, we just got to get the pieces picked up, okay? Pick up the pieces. You do your job, attack the homework and ask me questions. I'll do my job and not take a Thor's hammer to you on the first couple of tests, you know? 2 more slides. Sketch the graph. No, I refuse. I absolutely refuse, not because I'm lazy, but because I saw the weird look on your face when I put a log graph up on the screen. It means you don't remember it at all. No, I'm lying. I'm going to do it. Here we go. All right. If you're totally lost on log graphs, here's how you do them. Don't graph log base 3 of x. Graph y equals 3 to the power of x. That one you're supposed to know. How are you going to know it? Just sub in some x values. Stick with me. I'm going to sub in x value, not 0 yet because that's a problem yet still. I'm going to sub in x value 1. 3 to the power of 1, 3. Boy, panic. If you're not sure what I'm up to, panic. 3 to the power 2. What's 3 to the power 2? 9. So 2, I get a 9. 3 to the power 3. 3 times 3 is 9, times another 3 is 27. That goes right off the page. So someone, I forget who it was asking me about exponentials earlier, and I said, oh, they're shaped like this. This is how you know. If I've forgotten, I just put in a couple x values, and it goes off like this. What about x value 0? What's 3 to the power 0? 1. And as I go to more and more negative exponents, I just get things closer and closer to 0. Do you remember this now from grade 11? What exponential functions look like? Sort of like that. And there was 2 to the x, 2 to the x, 4 to the x, all these things. For you biology, chemistry type people, healthcare, those kind of things, exponential functions aren't going to disappear. These are the ones you really got to know. That's the ones they really care about. Okay. Whole log lesson, whole log grasping lesson in one moment. You can memorize log graphs. You can. It's a good thing to do. Or you can just go, okay, the inverse of log base, 3 to the x is log base 3 of x. If you want a log base 3 graph, you just have to do the inverse of the 3 to the x graph, which is so easy. 0, 1 becomes 1, 0. 1, 3 becomes 3, 1. 2, 9 becomes 9, 2. Are you with me on this inverse thing? I'm just taking each x and y pair. This approaches the negative x-axis. So this approaches the negative y-axis. There's a log graph. So if a minute ago I was laughing at you and you were freaking out about what log graphs look like, there you go. There's the whole lesson. That's the whole thing. You go back and watch the video on my YouTube channel. I'm going to do that. I'm going to take 15 minutes to do it. But basically I took 3 to the x, inverted the points, and got log base 3 of x. That's what log is. It's the inverse of log base 3. The rest of this, hopefully, is old news. This is where you get back to your guys' essential knowledge that you already have. What do I got to do to this log base 3 graph? Vertical reflection, vertical stretch times 2, a little left 4 type action. Does that part all ring a bell, though, when we get there? You give me the log graph. I can move it around all you want. So you can do that on your notes. Move that thing over. Check it with your calculator so you know you got that part of it down, okay? The part I needed to show you was how to get from 3 to the x to log base 3. Not bad there now? Now you're like, okay, I guess I can graph logs. I got a shot at it now. More time there? The compound interest formula. Evan invests $1,000 in an account. That gains 5.25% annually. So I don't have to do any of that semi-annually, quarterly nonsense. We'll leave that to the accountants for now. All I need is this. Oh, see? Now that was warming up to be a grade 11 question. In grade 11, then they would have said, oh, for 23 years or whatever. This time they didn't tell us the number of years. They don't tell us the number of years. Something I missed when I read the question the first time. They must tell me the final amount. What's the final amount? 2,500. And I'll simplify things a little bit, and then I have a question for you. What is it about this question that tells you logs are involved? Simon. Yeah, the unknown's up in the exponent. See? We're making progress already. 20 short minutes, we went from panicking about all this stuff to going, oh, log graphs, I got that now. Exponents, it's going to be logs involved here. So do some isolating. All the isolating you can. Log both sides. Because you can just do that if all that ln stuff was confusing you. And I'll pause here because this is the important moment in this. I guess I switched to the color pink in the middle of all that, did I? Why did I do that? Oh, it doesn't matter. Now what? Test yourself. Do you know what to do next? It's the whole reason for what I did, all this. What next? Yeah, that's the nice thing about logs. That's their superpower, if you want. Exponent up here, you can bring it down. And then I just isolate log 2.5 over log 1.0525. The one like this I put on the test. That woke you up. I think the answer is ridiculous because I made this number really big. So it's huge, but this one should work out nice. Log 2.5 divided by log 1.0525. Is someone else typing this in to check if I type it in right? I get 17.9 years. Anyone else get 17.9? 17.9 is a ridiculous answer. It's not going to take 17.9 years. How long before he's got $2,500? He's got 18 years is the answer to the question. I'm not going to bust you on stuff like that, but that's sort of real world type thinking. You know, where you go, there's no moment at 17.9 years where, yeah, I got enough money. You got to wait to the 18th year before you're going to get all that money. So, because it's only compounded annually. Okay, I just want to say this one more time. There's a lot of holes we got to fix up in the boat from coronavirus. Yes? But I'm there for you. How many times have I said, oh, the test question like this? I'm trying to lay it out for you so you know on this first one you're not going to get pummeled on this first test. But you got a job to do too. You got a monstrous job to do. 6 months of sleeping in until 1 o'clock or whatever it is, if that's what your strategy was. And sharing assignments. Let's take the cheating word out of it. That party's over now. It's time to roll. The world didn't stop doing math because coronavirus came along. In fact, we need you more than ever because it's pretty clear to me in the middle of coronavirus that nobody in charge of anything can do any mathematics, or else this wouldn't have got so out of hand. Yeah? They didn't know what the heck they were doing. It's a complete gong show. Took them forever to even talk to people that knew the math to help them in this. When you're voting for people later, maybe you vote for some people with some credentials as opposed to people who are just coming in off the street to run for office. Yeah? We need some people that have half a brain. Think about that for a second. We're 6 months later. We're right back where we started. The cases are almost back where we started, and we've got masks on. That's what we've come up with so far. Yeah? It needs more brain power. You guys, do your homework so you can be part of the solution. There's something else I want to say. Oh, redo the plan. Yes? Redo the plan. Magic time. I can't see if you're smiling, but you should be. The logistics of this whole thing just changed. Right? You come back. I still want you to do a bunch of review while you're away. Don't leave it all to Monday. And if you're like, well, you're not supposed to give us work during the week, that's okay. That's your weekend homework. Do this homework. Start some of the review. Nothing trig, because I haven't done the trig review yet. You'll come back on the Monday. I'll teach trig first thing. And then you have the rest of that day to do your review and your assignment that you've got. I'm going to give you that assignment in just a minute. And the practice test. So you got all that day and all that night to get ready. It's better than that. When you get back, I'll teach 2.1. And based on where we're at that point, we'll decide at what time of day we're going to write this test. We're going to get off to a good start. If we don't get off to a good start, it's going to be your fault for not taking the time I've given you to get something done. I'm not going to paint you into a corner because we've got all the way to April together. Yeah? We're going to get off to a great start. What do you want from me? A practice test. This is also online. Practice test with solutions attached. I remembered. And the assignment for this chapter. Listen, don't do that. You dummy. Who was here earlier when I did that? Did the monstrous feedback. Well, were you here when I... Sorry, I got 2 weeks of photocopying here. Oh, I found it. Every chapter, there'll be a beautiful assignment like this. If I say beautiful, these are 10 questions that actually some of them get quite challenging. It is not my intention that you just do this on your own. So I know I just did give you a lecture about cheating and sharing and all that kind of stuff. I'm not saying go ahead and cheat on this. I am saying that this is supposed to model university type assignments in that you get this thing, you got time to work on it, and you're supposed to learn from it. You know, you try it out, it's very difficult, and you work your way through it, and you see what you can come up with, And then maybe you do say to somebody, how did you get that? You took B. Why did you do B? Oh, because the absolute value. All right? They're not worth enough. I didn't make these worth enough in your mark to cheat. It's got to be about learning. It's got to be about pressing yourself a little bit and do your best on these things before you talk to other people. If it's not ready for the Tuesday and you give it to me on the Wednesday, that's okay. Use these to learn, not to show how good you are at cheating. Yeah? What else do I have to talk about yesterday? Is that it?